Calc BC, Unit 1, Review Corrective to get you ready for the retest. You should have tried this already, looked over your test, tried this as if it were maybe the test, then check your answers, go over it again. This has a lot of good problems that were similar on the test, but anything that was on the test that isn't exactly on here, that kind of problem is fair game still. So make sure you study your pretest, your test also. So we have some polynomial inequalities. So you want to move everything on one side. 6x squared plus 25x minus 9 less than or equal to 0. Just try and factor it. If you can't factor it, try and use quadratic formula. Rational root theorem would be for anything above quadratic because it's not guaranteed to work. So maybe we should, well, maybe it's like 6x and 1x, and then if I put a 3 here and a 3 here, that would be 21x. No, well, it's got to be a positive and negative. It's probably 9 and 1. So if you put a 9 here, that's 54. Now, so maybe we need to do 3 and 2. 3 and 2. If we do 3 and 3, that'd be 9 minus 6 is 3. No, how about a 9? Okay, put the 9 here, you get 27 minus 2x. Okay, so your roots are 1/3 and negative 9 halves. Set those equal 0, 0 product property. We do a line check. These are going to be solid dots, left to right, smallest to greatest. Test a point, tell me what you're testing. X equals 1, positive, 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 false, true, false. Interval notation, negative 9 halves to 1/3, brackets. Okay, next one. Move everything one side, standard form. We could try grouping, You're like, well, what's the GCF of the first pair? What's the GCF of the next pair? And if you get the same thing inside both parentheses, then you can do grouping, but we can't this time. So we got to do rational root theorem, which would work even, if grouping did work. So you got to make your list of P over Qs. P are the factors of the last term. Q are the factors of the first term. Plus or minus 1, plus or minus 3, plus or minus 9. Test them. Start with small, easy ones. If we plug a 1 in here, we get, positive 1 works. Got lucky. So now I'm going to do synthetic division. Put the coefficients in here. Any missing terms, put a 0. So 1, 5, 3, negative 9. Drop the first term down. Multiply, add, multiply, add. You should get a 0 at the end. Otherwise, you did something wrong. It's the wrong factor. Something's wrong. Okay, now that 1 comes from x minus 1. That doesn't disappear. It's not x plus 1, it's x minus 1. X equals 1 is the solution to 0 from x minus 1 factor. X squared plus 6x plus 9. Keep that inequality going. Factor this. X plus 3, x plus 3. I would rewrite it with the x plus 3's together with the power, because that makes it more obvious that it's going to bounce off the graph, right? So x equals 1, x equals negative 3. Line check. These are going to be open dots. Don't forget, things aren't going to go as normal at that negative 3. So I'm going to test far right. It's just what I like to do. 2, everything's positive, which is true. False, false. The answer is 1 to positive infinity. Now, if that were a solid dot, we would also put that on here as a single answer, but it's an open dot. So, all right. Do some rational inequalities. Very similar ideas and work. except the things in the bottom are vertical asymptotes, but they do have the same effect as a 0. The graph usually changes from positive to negative, which changes the inequality true to false. And a line check. This one's all ready to go. X equals 1, but watch out. X equals -4, x equals 0, x equals plus or minus 2. People love to forget that there's two solutions to absolute value equations. All right. So we're going to do line check, left to right. The ones on the top are going to be solid dots. -4, -2, 0, 1, and +2. Test the value. X equals 3. Seems good to me. Positive, 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 which is true. False. Stays false. Goes back. True. False. True. Okay, so the answer is -infinity, -4. Bracket. Union. -2 to 0. Parentheses. Union. 1 is an answer by itself. Union. 2 to positive infinity. I like these. These should be left to right in order as they appear on number line. So I don't want this 1 just thrown off to the end. I'd like it where it is. All right. Now the next one's a little more work because we got to move everything to one side first. And then we got to give them least common denominator. So this gets multiplied by x plus 3. So it's going to be x squared plus 3x. And this one gets multiplied by 3x minus 5. Distribute the negative. Minus 3x minus 5. Leave the bottom factored. Simplify the top. Factor the top. Or solve it. I mean, I like to think of it as difference squares. It's quicker than using. I think that's quicker than a couple other ways you could do it, but. All right, so we get x equals √5, x equals -√5, x equals -5/3, x equals -3. Now, let's estimate this radical, not for our answers, but just to make sure we put it in the right spot in our number line. It's between 1 and 4, so it's between 1 and 2. It's close to 4. I'd say like 1.7 or something. Oh, no. It's actually between 4 and 9, so it's going to be 2. I'm going to say 2.2. Okay. But at least if you write that, then I know, like if you mess it up, I know that's the reason you messed it up. Not because you didn't think about it or whatever worse possibilities. So this is like -2.2. So this would be the furthest to the left. And then, well, actually, the -3 should be further. -2.2, -1 2/3. And then +√5. Test the value. 3, which it's positive. Everything's positive. True, false, true, false, true. So -infinity, -3. Bracket -√5. It's -5/3. Parenthesis, union. Oh, this should be a solid dot. There's your answer. All right, let's do some absolute value problems. Now, absolute value problems is kind of like there's a variety of techniques. Like this one, I'm going to use that ruler pasta idea, but I got to get rid of anything in front of the x first. It's got to have a coefficient of 1 to make it easy. Okay, so then I say, okay, well, the middle of this is at 2. And absolute values are distance from what's in the middle. So we want things that are more than 5 away or equal to it. So that's going to be solid dot at 7, solid dot -3, but less than 9 away. And those are going to be solid dots. So that's going to be at 11. And that's going to be at -7. So it's more than 5, but less than 9. So it's got to be in between those. These ones, this is a mess if you do it kind of traditional way. 4 different cases with ands and ors all mixed in. So the way that makes it a lot easier is just square both sides because that gets rid of the absolute values. But you got to FOIL it. 9x squared minus 12x plus 4. X squared plus 8x plus 16. Move everything to one side. Now it's polynomial inequality. Always take the GCF out first. I feel like I made a mistake somewhere. Oh, this is 20. We take 4 out. That's going to make any technique easier, even if you use quadratic formula. Small numbers easier. Now, factoring this, let's see if we can factor it. It's got to be a 1 and a 3, a positive and negative. We want -5, so -3 here gives you -6, plus 1 here gives +1. You get -5 in the middle. Do a line check. These are open dots. Test a point. Tell me what you're testing. False, true, false. Now, just, like I said, this isn't, if you had 3x minus 2 equals x plus 4, don't square both sides. Don't square both sides. Just do inside equals inside, and inside equals the negative of the other inside. That's way easier. That's the way to do it. If you square both sides, it works, but it's up to you. Okay, we got some trig. So I'm going to isolate the trig. Now, I want degrees for this answer. If they give you the domain like that, that means that's what the answer is going to be. Okay. Unless it says something else. If it's, if it says radians, do radians. If the answer degrees and radians, do both. Okay. Now, alpha, when does sine equal √3/2? So it starts at 0, 1/2, √2/2, √3/2, 1. 0, pi over 6, pi over 4, pi over 3, or 60 degrees. 0, 30, 45, 60. You could write the radians in this. That's fine. But for answers, let's just go with degrees. What quadrants are we in? We're in quadrants 1 and 2. That's where sine is positive. So we're going to do 3x equals 60 degrees plus 360k, and 3x equals, quadrant 2 would be 120 plus 360k. And we divide by 3. Solve for the x now. We should get 3 times as many answers as we usually get because of that 3. So we should get 6 answers. It's good to just know. 20, 140, 260, 40, 160, 280. Okay, next one. We got inequality. So we got to find the root still. I think we should factor sine 2x out, GCF. And then here, sine 2x equals -1/2. So alpha equals pi over 6 or 30 degrees. Quadrants 3 and 4, so it's negative. This over here, this is going to be 2x equals 0 plus 180k. So it's going to be x equals 0 plus 90k. 2x equals, quadrant 3 is going to be 180 plus alpha, so 210 plus 360k. And quadrant 4 is going to be 360 minus alpha, so 330 plus 360k. 5 by 2. So here we get x equals 0, 90, 180, 270, 360. All right, here we're going to get 105, 285, 165, 345. So, number line time, got a lot of points. I like to put the restrictions on here. So, it was 0 degrees, but that's also, these are all solid dots. 0, I'd like to check them off. It's easy to miss one. So 90 would be next. And then 105. And then 165. And 180. And then 270. 285. 345. And 360. So I think that's all of them. This is also the edge, because there are more roots to the left and right. Now I don't test extreme ends on these usually. I just pick what's the easy point. So I love 0, or 90 or 180. Unfortunately, those are all taken. But also remember that whatever you're playing here, you can double before you take the angle. So like 45 would be nice, because then it's 90. So sine of 90 is 1. So you get 2 plus 1 is 3 times 1. It's 3 is false. False, true, false. And you guys remember how to figure out if it bounces off the graphs of these? It's if sine or cosine, when you isolate it, when you're solving it, equals plus or minus 1. There are none on this one. And it keeps going after that, and then starts switching again too. This is an answer. That's why I put those very clear solid dots or open dots, because that helps me make sure I don't miss an answer. 90 to 105, 165 to 180, 270 to 285, and 345 to 360. And you might be like, well, you write all those degree symbols? Yeah, because if you don't write a symbol for angles, then it's radians, which is not what we're doing. So, okay, we've got some log exponential stuff. Solving log equations, you want to get to either log equal log or log equal number. This looks like a log equals a log situation. So we use log rules to combine these together. It's going to be 100x. And then you can set their insides equal to each other. Now, don't divide by x, because you're losing a solution. Move it to one side, equal to 0, like we've been solving everything. Factor it. So we get 0 and 50. Now, the thing you got to watch out for on logs is you might get answers that are outside their domain. Like you can't take logs of negatives, so x can never be negative. You can't take logs of 0, so x cannot be 0. So it's just going to be 50. But I want to see in your work, and that you decide not to use it. Okay, next one, final solutions where this is less than this. Well, we could exponentiate both sides to get rid of the natural log. E to the 0 is 1. And now it's a rational inequality, so you need to move everything to one side. Give the least common denominator. So you got to multiply top and bottom this by x minus 1. So it's going to be x minus x plus 1. So it's going to be 1 over x minus 1. So x equals 1, line check, open dot, test a point. X equals 2 is false. True. Now here's the deal. You got to watch out. Just like I was talking about over here, you might get answers that are not actually in the domain of the problem. So you need to consider the domain of the problem. And on inequalities, that's more complicated than just, well, if it's negative, 0, get rid of it. The domain is the inside of the log or natural log has to be positive, not or equal 0. Just what's inside. So this is another, and write domain next to it if that's what you're doing. Line check. These are open dots. Test a point. It's true, false, true. So this is the domain. If it helps, you could rewrite the other one below it to line it up. And they have to both be true. So it's like there's word and in between. So they got to be overlapping. So the answer is negative infinity to 0. You got to do both. If you don't do both, you're losing lots of points right off the bat. Okay, inverse trig. I want these ones in degrees and radians. It doesn't say that here, but on the test it did. So degrees and radians for answers that are angles. So this one we're saying, okay, well, what's alpha? When does cosine equal root 3 over 2? Ignore the negative first. So it's that first angle, 30 degrees, pi over 6, right? And what quadrants? Quadrant 2 and 3 is when cosine is negative, but these are principal values because it had inverse trig already into it, so it should only be one answer. So it's never quadrant 3. It's quadrant 1 and then 2 or 4 depending on the function, so it's got to be quadrant 2. So the answer has to be in degrees, 180 minus alpha, 150 degrees. In radians, pi minus pi over 6, 5 pi over 6. So I want both of those. Okay, this one, this is not one we've memorized. So we can't find the angle, but we could draw a picture because we don't actually need the angle in the end because we're going to take sine of that angle. So we just need all the values associated with that angle. So I find a picture to be helpful here. This is adjacent over hypotenuse, right? Oops, I'll do this problem. I skipped B. I'll come back to B in a second. Okay, adjacent over hypotenuse. Adjacent is the one. Now it's got to be positive. Adjacent. Hypotenuse could be here or it could be here. So we're looking at these two different situations. It's either quadrant 1 or 4. Now, principal values says it's always quadrant 1. So it's got to be quadrant 1. Now what we need to do is find this side right here, the opposite side, so that we can do sine. Sine is opposite over hypotenuse. All we need is opposite side. So we need to do a little Pythagorean theorem. Y squared plus 2 squared equals 3 squared. Y squared plus 4 equals 9. Y squared equals 5. The square root of both sides, plus or minus, because it could be negative. If it was down here, it would be plus or minus root 5. So this one's the positive root 5 because it's up. This is the negative root 5 because it's down. We're going to make use of the positive one. So root 5 over 3. Back to 11, part B. When does tangent equal negative root 3? Well, I don't memorize tangent values. So I know it's sine over cosine, right? Sine over cosine. So I want to think of this as a fraction. So maybe root 3 over 2, 1 over 2. And then alpha, well, it should be the same one. Ignore the negative for a second. When does sine equal root 3 over 2 and cosine equal 1/2? Well, that's, sine is 0, 1/2, root 2 over 2, root 3 over 2, 1. So 0, 30, 45, 60, or pi over 3, 0, pi over 6, pi over 4, pi over 3. Same thing for that. What quadrants does sine and cosine have opposite signs? So it's not just that sine has to be negative and cosine is positive. It could be cosine's negative and sine's positive. So they have opposite signs in quadrant 2 and quadrant 4. But we're doing principal values. So it's always quadrant 1 for all of them, and then a quadrant tied to quadrant 1 that gives the other possible answer. So quadrant 1 would give you the positive answer. So quadrant 2 or 4, either of them would do it. I think it's quadrant 4 for tangent. Oh, it's a little less obvious. I guess you could go with what are the quadrants for sine would be quadrant 1 and 4. Right? And cosine is going to be quadrant 1 and 2 usually. Tangent looks like this. And we use this chunk of the graph. Inverse tangent looks like this. We're using that middle band. So we're using quadrant 4 and 1. That was a little hard. Yeah, it's quadrant 4. Okay, so quadrant 4 now. Here's the deal. This is what some people do. They say, well, quadrant 4, well, that would be 300 degrees and 2 pi, 5 pi over 3. Nope, that is quadrant 4. But in this case, you have to go backwards into it. It needs to be negative 60 degrees, negative pi over 3. Principal values. It's quadrant 4, but it's backwards, attached to quadrant 1. Okay, B, similar to 12B, similar to 12A. Trying to find an angle here, right? And so this is opposite over hypotenuse. So you could draw a little picture. So opposite is up and hypotenuse is here. So this is x plus 1. It could be over here, right? But principal values, it's always quadrant 1. So tangent is going to be opposite over adjacent. So we need to find this missing side right here, which I don't want to call x because that's confusing with this. I'll call it a for adjacent. So a squared plus x plus 1 squared equals 1 squared. So a squared plus x squared plus 2x plus 1 equals 1. So a squared equals negative x squared minus 2x plus 1 minus 1 cancel. We take square root of both sides, plus or minus. And I mean, we can't really simplify this anymore, right? But it's the positive one that we want right here because this would be the negative one over here. But that's why you should have plus or minus in your work. I'll probably take off points if we don't do plus or minus. So tangent is opposite over adjacent. And I'm okay with this as your answer. If you really want, you can rationalize the denominator. It doesn't make it any prettier. Okay, if you want. All right, there you go. Make sure you're ready for the retest. And make sure you study anything from the original test just in case it wasn't really on here. This is just some extra practice.